Hi, this is Scott Allen, and this module is an introduction to ASP.NET MVC 4. This module will give you an overview of what is new in ASP.NET MVC 4. If you've never worked with ASP.NET MVC before, I'll be building a simple application to demonstrate the basics of the framework. But even if you have worked with ASP.NET MVC previously, the demo will show off some of the new features for version 4. Let's look at the release notes for MVC 4. If you go to the ASP.NET website, you'll find some release notes for MVC 4 that list the new features for this version, as well as how to install the framework and update existing applications. One of the new features for version 4 is the ASP.NET Web API. This is a framework for building web services that embrace HTTP. I have a module dedicated to the Web API in this course, and John Flanders also has an excellent course dedicated to this topic. The mobile features of MVC 4, including the mobile project template and display modes, these are covered in the mobile module for this course, and if you're interested in more information on jQuery Mobile itself, I also have a course dedicated to that topic. The task support for asynchronous controllers is the focus of the async module in this course. Asynchronous controllers allow you to keep an application scalable even when you have a lot of long-running network calls to make from your controllers. And the bundling and minification features allow you to optimize your JavaScript files and CSS style sheets for download. We'll take a look at the bundling and minification features of MVC 4 in the optimization module. Finally, this module will cover just about everything else. We'll build a small application from scratch and see how to use database migrations, how to deploy to the cloud, talk about the MVC design pattern and see how controllers, views, and models all work together. And I'll also talk about some of the enhancements to the default project templates. From here on out, we'll be using Visual Studio 2012 to build a web application, although you can do everything I'm going to do with Visual Studio 2010 also, because ASP.NET MVC 4 will happily install itself into Visual Studio 2010, and there's nothing special I'll do with 2012. The application I want to build will be a simple application to manage the employees of a company. Every employee will be in a department, and I at least want the ability to list and add employees to a department. I'm going to primarily focus on the mechanics of ASP.NET MVC, and I won't go into any details on ancillary topics like unit testing. But I will point you to some resources on those topics when we get to certain points, because Pluralsight does have a vast library that covers everything else like unit testing, design patterns, and AJAX. One way to get started with ASP.NET MVC 4 after you install it is just to say File, New Project, select the ASP.NET MVC 4 Web Application Project template, give it a name, click OK, and you're off and running. I'm going to do something slightly different just to show you what the possibilities are. And under Other Project Types, Visual Studio Solutions, I want to start with a blank solution actually. And I'm going to call this Solution eManager, or Employee Manager, Electronic Manager, however you want to think of it. And now if I open the Solution Explorer window, I have a solution, there's no projects inside yet. Instead of starting with an ASP.NET MVC project, let's get started with a project that represents the entities and the business objects that I care about. So I will put those inside of a Windows class library, which produces a DLL which you can reference from other projects. And I'll call this emanager.domain or emanager.core. The idea is to have a project here, an assembly that I can reference that just has some C# code inside of it for the objects that I really care about, things like employees and departments. Once this project is ready to go, we'll add some code in here to represent employees and departments. Let me delete class1.cs that comes here automatically, and let's instead add a new class called employee. I want employee to be a public class, and every employee is going to have an identifier, an integer ID. Every employee is going to have a name. Of course, we could also have first name and last name, but I'm just going to stick with name for now. And I think that's enough to get started with, actually. Let me also add a class to represent a department. And every department, this will also be a public class, is also going to have an identifier, is also going to have a name, and it is also going to have a collection of employees. So you can have 0 or more employees inside of any given department. And before I forget, let me also add one more thing. I'm going to hold down the Alt key and make a selection across 3 different rows and then start typing. That's a feature that's been available in Visual Studio since 2010 that allows you to do a columnar selection. And I'm going to add that to employee also. And the reason I'm doing this is because the entity framework can do very efficient change tracking and add additional features to an object if you make your properties virtual. We'll see that in a bit. And now let me add one more type inside of here. I want something that represents a data source. So maybe I could call this department data source. And I'm going to put this inside of this assembly, this project, because it's really just an abstract interface definition that represents how you would get to employee and department information. Add properties of type iQueryable to this. That's something that you can query with LINQ. These don't need to be public in an interface definition, but I want a queryable set of employees. I want a queryable set of departments. And we really just need getters on here. We don't need setters. You just need to be able to get to employees, get to department. And chances are we'll need to come back and change some of these definitions later, but that's okay. Let's find out where we are first. We have departments, we have employees, we have a data source or an abstraction for the data source to get to the information about employees and departments. Now let me come in and add a new project. This one is going to be an ASP.NET MVC4 web application, and we can call this one emanager.web. When you create a new MVC4 application, you have your choice of templates that you can use to create that application. The empty template gives you a web application that really doesn't have much of anything inside of it. There's no scripts, there's no style sheets, there's no default views. So if you know exactly where you want to go with the project, the empty template might be for you. I'm going to select the Internet application template. The Internet application automatically comes with a home page and a layout view and some scripts and style sheets. It has an account controller that allows users to sign in, allows users to register for your website. An Internet application assumes you're going to publish this somewhere on the Internet. The intranet application offers many of the same features as the Internet application, but intranet assumes you're inside of a firewall, you have Active Directory available, and your users will primarily come into your application as authenticated Windows users. There's also the mobile application project template, which we'll talk about in the mobile module of this course, and the web API template, which we can talk about in the web API module. So I will create Internet application and select OK. Again, we won't be talking about unit testing. If you want to see more information about unit testing, there are a couple great unit testing modules and courses out there on pluralsight.com. David Starr has done some of that work. I've done some of that work. I also cover unit testing in an MVC application in my MVC3 course. Everything in that course still applies to this course. And also I touch on it in my LINQ architecture course, which talks a lot about how to build abstractions that make for a testable application. So you can see that project took a little while to create. And one of the reasons is this. If you've done any work with MVC in the past, you might be aware that the MVC project templates add a lot of things into your project, like the jQuery library and other libraries and assemblies. If you ever needed to go through and update jQuery, then you had to go out to a website and download jQuery and copy the library into your project. With MVC4, things are a little bit different. If you're familiar with NuGet, and again, that's another topic that we have available as a course here on Pluralsight, NuGet is an extension for Visual Studio that can help you manage dependencies and libraries inside of a project. And one of the files that NuGet will leave behind is a packages.config file that tells you everything that's installed into an application. And here we can see libraries, JavaScript libraries like Modernizer are installed. Libraries like the Entity Framework here are referenced as a NuGet package and not just a plain reference, because that makes it very easy to update any of these components. I can go into Manage NuGet Packages after I right-click on References. I can see what updates are available. And for example, if I wanted to update jQuery, hopefully jQuery will appear as an update here in the list of potentially updated NuGet packages. There we go. I can update jQuery, jQuery validation, jQuery UI. I can update all these libraries really easily because they've been installed as NuGet packages with MVC4. But let me close this and just run the application to make sure we have something that is working. So I will set emanager.web as the startup project. Hit Control F5 to run without the debugger attached. And this is our new MVC4 application. Let's talk about some of the structure behind this. Here's how the home page before you works. ASP.NET MVC is a UI technology based on the model, view, controller design pattern. In the MVC pattern, you separate your UI code into distinct components. You have models, you have views, and you have controllers. The models contain the data to display and some associated logic. The controllers are responsible for receiving a request and figuring out what to do. They often build a model, and then they select a view to display that model. The view then is responsible only for taking the model from the controller and producing the HTML that you see in the browser. Each component has distinct responsibilities in MVC, so you don't have all the code jumbled together and becoming difficult to work with. When I make a request from this browser, like to localhost 9027, the runtime will go looking for a controller to process this request. And in MVC, that is part of the routing logic. Routing is something that's configured during the start of an application. And in ASP.NET, that means it happens inside of a special method named applicationStart that lives in a special file called global.asax.cs. There's all sorts of configuration happening in here, but it's broken out into different classes. There's bundling configuration, which we'll talk about in the optimization module, and filtering configuration and routing configuration. There's a call to a method called register routes. This class, route config, and its method, register routes, lives in a folder app_start. Inside of here, you'll see all sorts of configuration classes, and this is a little bit different than what it was in MVC3, where we had all of the configuration jammed into the global.asax.cs file. Now all of that configuration code is inside of classes that are in the app start folder, and we just call into them during the application start event. Let me open up the route config file, and we can see that there are two routes inside of here that are defined. One is for Web API controllers. We'll talk about that in another module. And then there's the route known as the default route. What a route specifies is a pattern for the runtime to match against an incoming URL. So if a request arrives for what you see in this comment here, /department/detail/3, the runtime knows to pick that apart and to go looking for the department controller and then invoke the detail action on that controller. We'll talk about actions here in just a bit, and possibly pass along an identifier as 3. So pass along a piece of data to that controller action that tells it, hey, the ID you're looking for is 3. There's also some defaults specified for each route. So if a part of this URL is missing, the MVC runtime can substitute values. For example, if the ID didn't exist here and we just had a request for /department/detail, that's okay. The ID is optional. It might show up as null in our controller action. If we don't specify an action in the URL, then the controller knows that it just needs to go looking for the department controller, but then the default action is index. So invoke the index action on the department controller. And if a request arrives for the root of the application, we have enough defaults to plug in values for everything there too. The controller will be the home controller, the action will be the index action, and the ID is still optional. And what that means is if I go back to the browser where this is running, I can make a request to /home, that arrives at the home page, and I can make a request to /index, and that arrives at the same page, and that's all because the defaults were /home/index. If I try to go somewhere that doesn't exist, like /foo, and there is no foo controller, I get back an HTTP 404 message. That could also happen if I look at the controller. So all of the controllers for ASP.NET MVC are in the controllers folder by default. They don't have to live here. You can put them in any folder. You can even put them in a different project. But if I open this up and comment out the home controller and then do a build, the home controller no longer exists. So if I refresh /home/index, we should also get a 404 message. Doesn't exist. Essentially, that's the runtime telling you that it cannot find something to process this request. Let me show you a little more about how this works. Let's say we did want to respond to a request for /home/sayhello. Currently, of course, that returns a 404 error. That means I would need a home controller. So let's flip back into our homecontroller.cs file and write a public class that is the home controller. So literally, the controller name starts with the word home, and it needs to derive from a base class provided by ASP.NET MVC, the controller base class. There's also an interface at a very low level you can derive from, but the controller base class is good enough for what we want to do. Now the action part of the URL, say hello, gets parsed into the action. That will literally be a method name that the runtime goes and looks for. So I could create a say hello method, in other words, a say hello action. And just by having that in place, if I do a build and I refresh the browser, we should no longer get a 404 error, but we get a blank page because that say hello action isn't doing anything. I could have the say hello action do something like return a string, just return a string, hello world. A little bit off on the capitalization, but that's okay. If I do a build now and refresh, I should see the text say hello. And there's no HTML involved, there's no JavaScript, CSS. It's literally all we sent back from the server is just the text hello world that shows up in the browser just fine. But what you typically do in a controller is you put together some sort of model by querying a database or querying something on the file system, putting together a model and handing it off to a view. At this point in time, we're not dealing with any models just yet. I've uncommented the home controller. You can see all we do in the index action is just set a message in this property called viewBag and say return view. ViewBag is one way to tunnel information from a controller into a view. Every view has access to viewBag. It can pull out things like the message. We'll see that in just a second. Return view is just a fancy way of saying the next thing that I want to do is I want you, dear MVC runtime, to render a view for me. But which view? It's going to be what we call the conventional view for this particular controller action. In every ASP.NET MVC project, you will have a views folder. By default, that is where your views live. If you have a home controller, then the default view for the index action of the home controller will be a view that lives in the home folder under views, and it's called index. So you can see there's a naming convention in play. If I were to rename this as index 2 or index 3, the MVC runtime wouldn't be able to find it unless I went in and explicitly told it, well, the view that you should use is index 3. But in this case, I'm really just want the default view, which is the index view. I could specify it explicitly there. By putting everything back together like this, we should be able to get the home page that we saw earlier again. Of course, I need to remove the say hello part so that we go to the index action. And there's our home page. Let's look at this view. This view, under the views folder, consists of most of the HTML that you see there on the screen, and you can see that it includes a viewBag title, viewBag message. The title is actually set up here. This is a Razor view. It has a CSHTML extension. Razor views are just a way to intermingle HTML markup and C# code. Wherever you see an @ sign, that is usually the beginning of a C# expression. Of course, you can also have literal @ signs. If you escape it, that would be displaying @viewbag.title literally in the browser, but we want it to display the result of evaluating the C# expression, which is to display viewbag.title. You can see it's really quite clever about knowing when you have C# code and then transitioning back into markup mode. In fact, viewbag.title This extra dot here would normally be a compiler error if that was in a C# file, but in Razor it's smart enough to figure out that, well, that doesn't make sense as an expression. You must literally want to display a period here after the title. So Razor's pretty sharp about that. And you might be wondering, well, all of the HTML that I see here is not entirely indicative of what I'm seeing on the home page. For instance, there's no register link, there's no login link. Where does all that stuff come from? That comes from a layout template that is also a Razor view that's part of this MVC application by default, and that is in the shared folder. Any view that you put in the shared folder is available to all controllers anywhere, and this is typically where you find the layout view. It's the layout view that defines the head tag, the body tag. It's the layout view that is rendering those links in the menu at the top of the page, the home link, the about link, the contact link, and it is the place where you call render body in this view where index.cshtml will appear. When your home controller says render the index view, then everything that you see inside of here that's not in a section will be rendered when the layout view calls render body. The sections will be rendered at the point where that particular section is rendered in the layout view. So when this says, please render the section called featured, then in the index view there will be a section featured that contains the markup that gets placed at that location. Ultimately, what I'd like to do is to display a list of departments on this home page to allow users to start viewing departments and adding employees to departments. So let's just call this the Department Manager page, and I'm going to delete all of the other markup that was inside of here. And if I refresh the browser, we should see those changes reflected here. Now my index view just shows the markup Department Manager. Everything else that you see here, the copyright, the obligatory link to Facebook and Twitter, those are all part of the layout view. I could go into the layout view and change that stuff too. But now you've seen that we have a controller that responds to /home/index, or just /home, or just / to the root of the URL. It's not putting together a model yet. We don't need this viewbag.message anymore. And it's rendering what we call the conventional view, which is the view that has the same name as this action on the controller. So the index action of the home controller. And what I'd like to do next is have this index action get a list of all the departments that are going to be in my database and hand that off to the view so that the view can display the departments in a list here. And to do that, we'll need to get set up with a database.